Hello, fellow mathematicians. This is Ms. Backfish, and I am here to talk to you about solving rational equations. Now, what does that mean? What is a rational equation? Well, it's one that basically has an x in the denominator. Now, this is not a rational equation. However, the technique we use for solving rational equations is the same technique I would use for solving this equation. So let's start here. All right, I've got fractions. I definitely have denominators, even if they don't have any x's, any variables in the denominator. So that's why we need to deal with it in a certain way. You could certainly deal with this as if it said 1/12 of x plus 2. Let me rewrite it this way, as if it said 1/12 of x plus 2 equals 3/5 plus 1/6 of x minus 1. That actually says the exact same thing that you see up here. And that's why it's really not rational, is you don't have any variables in the denominator. But when you have a fraction and when you have an equation and there are fractions in it, it can be very convenient to get rid of them, to get rid of the fractions. And I want to show you how to do that. What you want to do is you want to look at your denominators, all of your denominators, and you want to think about what is the smallest number they all go into. In other words, the least common multiple of those denominators. For instance, 6 goes into 12, so 12 is the least common multiple of 6 and of 12, but 5 doesn't. Least common multiple of numbers means that those numbers can be multiplied times something else to get that. For instance, multiples of 5 would be 10, 15, 20, 20. Smallest number that all of those numbers go into easily is 60. Sometimes that's the easiest way to find it, is to multiply some of the numbers. In other words, 6 goes into 12. So I really don't have to worry about the 6. I already know it goes into 12. If I think about what 12 and 5 both go into, then that can help me find my least common multiple. So 12 times 5 gives me 60, and I found a number that they both go into. Now technically, you don't have to use the least common multiple for this method. You can use any number that all of your denominators would divide into. All right, so 60 is a number that 12 and 5 and 6 all go into. So what I'm going to do is I'm going to multiply both sides of this equation by 60. And I like to break it down like I'm multiplying every term, because that's what happens if you multiply both sides by 60. It gets distributed to every term. Remember, it's okay to do whatever you want to both sides of the equation as long as you do it to both sides of the equation. Multiplication, division, etc. You can do that to both sides of the equation. Now notice that I put the 60 up here by the numerators. I didn't put it sort of in the middle, and that's because really it only affects the numerators. 60 is really the same as 60 over 1. So it's like I'm multiplying by 60 over 1. And when we multiply fractions, we do top times top, bottom times bottom. So 1 times 12, that's not going to change at all. So really the 60 is only impacting my numerators if it gets multiplied in there. But before I multiply out, before I do that top times top, bottom times bottom, I'm going to simplify. Because now I have a 60 on top and a 12 on the bottom, and the whole point of using 60 was that 12 goes into it. 12 goes into it 5 times. So I'm going to say 12 goes into itself once and into 60 5 times. Then I'm going to do the same thing over here. 5 goes into itself once and into 60 12 times. I'm reducing 60 over 5 to 12 over 1. And then over here, 6 goes into itself 1 time and into 60 10 times. And what should happen at this point, and that's the whole thing we've been heading for, is we don't have any more denominators. All we have in the denominator is 1. So now, really, I don't have any fractions. I just have, make sure you see everything that still remains. I have 5 times x plus 2 on top there equals 12 times 3 plus 10 times x minus 1. Make sure you use parentheses if you need to. So now I get to distribute. Now it's basically just a regular old equation that we can solve the way we do anytime we don't have fractions. So 5x plus 10 equals 36 plus 10x minus 10. Collect all my variables on one side. I'm going to move this over to the left. And I have negative 5x over here. I'm going to move the 10 over here. And I have 36 minus 10 minus 10. That's 16. And x equals negative 16/5. Let's do another one. All right, I have denominators, so the first thing I ask myself is what do 4 and 2 and 8 all go into? Well, this is a case where they all go into one of the denominators. Everything goes into 8 there. In other words, 8 is a multiple of 4, it's a multiple of 2, and it's a multiple of itself, so that's the least common multiple. It's like thinking about what would be a good common denominator. It's just that we're not going to make it a common denominator because we don't want denominators at all. So 8 is my number, and I'm going to multiply every fraction by 8. Then I can cancel. Let me change color pens here. 4 goes into itself once, not the best choice maybe, and into 8 twice. 2 goes into itself once and into 8 4 times. 8 goes into itself once and into 8 once. So 8 over 8 is just 1, so that basically goes away. It's just 1 times 5 here. So now I have on top 2 times 3x minus 8x equals 4 times x, no fractions left, minus 5. So that's 6x minus 8x equals 4x minus 5. Negative 2x equals 4x minus 5. Subtract 4x from both sides to collect my x's on one side. And I will get, when I isolate my x, that x is equal to 5/6. Negative divided by negative is a positive. Next up, let's look at now some rational equations using the exact same technique. So here we go. I have an x in one denominator, a 4x in one denominator, and 8. So basically now I want to know what is the least common multiple of x, 4x, and 8. So the thing that x goes into, 4x goes into, 8 goes into. I like to think of the numbers and the variables kind of separately. Here's what I've got in terms of variables. I've got an x, here's an x. I know that my least common multiple needs to have an x in it because that's the smallest multiple of x is just going to be x. All right, 4 and 8, well, those both go into 8. So 4 times 2 is 8, and 8 times 1 is 8. So this is my least common multiple. Okay, and I have a separate video you might want to watch if you're having trouble coming up with your least common multiple, because there is a more strategic, methodical way of doing that that we can get into. That's just kind of breaking it down even further. So here we have 8x as the smallest thing, the smallest multiple of x, 4x, and 8, the smallest common multiple they have. So I'm going to multiply by 8x on every term. All right, so now I get to do my canceling. I get to do my reducing. X over x. Excuse the notification symbol. X over x simplifies to just 1. So that's gone. Then 8x, x over x simplifies here. 8 and 4 simplifies to 2 over 1. 4 goes into itself once and into 8 twice. 8 over 8 simplifies to 1, and that's it. Be careful that you definitely see everything that's been left behind. You kind of have to keep your eyes peeled here at this stage to make sure you don't leave anything out. So 8 times 5 is left, plus 8x times 3 equals 2 times 2. plus x times 7. So I have 40 plus 24x equals 4 plus 7x. I am going to move my x's to the left. That would give me 17x. And my constants or numbers to the right. That gives me negative 36. And x is equal to negative 36 over 17. That doesn't reduce. So there's my answer. Now, because we have x's in the denominator, anytime you have x's in the denominator, there is something special you need to do here. You can do it at the start of the problem or you can do it at the end of the problem. You need to make sure you're not going to do anything that would make a denominator equal to 0. That's a problem. Those are called domain restrictions or values that are not in the domain. You can't ever have a fraction with a denominator 0. So you can either start at the beginning of the problem and ask yourself, what would make this denominator 0? What would make this denominator 0? Anywhere there's an x in the denominator, anywhere there's a variable in the denominator. And the answer here is x being 0. So as long as x isn't 0, we're fine, and that's not 0. The other alternative is you can wait till the end of the problem, you can get your x value, and then you can go back and plug it in and see if it makes any denominators equal to 0. If it does, you would throw it out and you would call it an extraneous solution. But in this case, it does not, so we're good. We can move on. All right, next up, here's another one that has a rational denominator, and I'm going to ask myself at the beginning here, what would make any of these denominators equal to 0? Well, I need to make sure x plus 2 is not equal to 0, which means I need to make sure x is not negative 2. So at the end of this problem, if I got negative 2 for x, I would throw it out and say no solutions. Now let's go ahead and think about solving it though. All right, we only have 2 denominators and they're identical. That's not true really. We have another one here. So I need to make this, I need to deal with that, the fact that I can't just leave it like that and get rid of denominators. So what I'm going to do, they are identical, so I do know the least common multiple of x plus 2 and x plus 2 is x plus 2. So that's what I'm going to use. I'm going to multiply by x plus 2 on top on every single term. That's my least common multiple. The only place it's going to stick around, though, is on this one, because here that will cancel. X plus 2 over itself is 1. Here it will cancel. X plus 2 over itself is 1. And here it sticks around. So now we have 3 for this term plus 3 times the quantity x plus 2 equals 15. Why did I say the quantity? That's just a fancy way of saying all of this is in parentheses, so don't worry about that. 3 plus, distributing, I have 3x plus 6 equals 15. I can collect the 6 and the 3 together as 9. Once you get rid of the fractions, you're just solving as usual. And I got x is 2. Is 2 okay? 2 plus 2 would give me a denominator of 4. That's perfectly fine. The only thing that would have been problematic is if I got negative 2. So this is my solution, and I am good. All right, moving on, I want to show you just a couple that have a little bit more complicated denominators. All right, let's look at this fella. Okay, I'm not sure why I gendered it. It could be either way or any which way you want. But we have x plus 2, x minus 4, x plus 2 times x minus 4. So my denominators, all of the things I need to worry about are x plus 2 and x minus 4. And they go into this. Remember that if you can't figure out what is the smallest thing these two numbers or these two expressions go into, one way to find out is to multiply them together. And that's what's happened here. Now notice that this problem didn't necessarily have to look like this. Sometimes you'll get the exact same problem. These are the same problem, but this denominator is not factored out. If you are looking for your least common multiple, you're going to have to factor out anything that needs to be factored. You're going to have to factor everything out so that you can compare and find out what are all the factors that need to be included in my denominator. So this is factored form is up here, And then you can see that as long as I have x plus 2 and x minus 4, we're good. So I'm going to multiply everything by x plus 2 times x minus 4. All right, now, some of these things are going to cancel, some of them won't. X plus 2 cancels, x minus 4 cancels here, and the whole thing cancels here. So let's look carefully at what remains. 4 times x minus 4. Make sure to keep the parentheses. Plus 5 times x plus 2 equals 30. And now I have my equation to solve, and it becomes a lot simpler without all the fractions. And I have 9x minus 6, 9x equals 36, and 9 equals 4. Excuse me, not 9, x equals 4. Okay, so now what did I not do at the beginning of the problem? If you don't do it at the beginning of the problem, you have to do it at the end. And that is, when you have any variables in your denominator, you have to make sure nothing's going to turn into 0. If I take x equals 4, and I go back up here and I plug it in, 4 plus 2 is 6. That's fine. But right here, that is not okay. That's going to give me 4 minus 4, which is 0. So this becomes what we call an extraneous solution. And I'm going to mark through it, and I'm going to say that's extraneous. Some teachers like you to actually write that, but my actual answer now becomes no solution. Or the empty set if you're doing it in set notation. All right, last example. We're going to do another one just like this, but without having it factored for us to begin with. Here we go. Remember, you could right now stop and ask yourself what would make these denominators 0, but I still won't know that until I get this factored. So let's go ahead and factor x squared plus 2x minus 35. When you have no leading coefficient other than 1, in other words, it's 1x squared. It's not 2x squared or 3x squared or 15x squared. The easiest way to factor these would just be to ask yourself what two numbers multiply to give you negative 35 and add to give you 2. That's what I need, is two numbers that multiply to give me negative 35. Their product is negative 35, and the same two numbers have to add up to positive 2. The signs matter here. Think about the things that multiply to give me 35. Well, this problem kind of gives me a hint. 7 and 5 makes 35. And if I do a positive 7 and a negative 5, that's going to work out perfectly. So this factors as x plus 7, x minus 5, which is nice because that already includes both of these other denominators. So my least common multiple, or my best common denominator here, would be that, the part that's written in red, both of them together, x plus 7 times x minus 5. So that's what I'm going to multiply on top by in each case. And remember, I only need to worry about doing it on top because it's like it's over 1, and multiplying by 1 doesn't change my denominators, so that's okay. There we go. Now I'm ready to cancel out any common factors because that makes a 1. And Amy, looking for a better color here. How about this one? Not very bright. X minus 5 cancels. Sometimes I like to shade out things that are canceling. X plus 7 here, and the whole thing cancels here. So that means the denominator is just 1, which means we don't really have a denominator, which is what we wanted. So what's left? 1 times x plus 7. So that's just x plus 7. Uh-oh, I left the lid off my marker. Minus 4 times x minus 5 equals 12. So x plus 7 minus 4x plus 20 equals 12. Negative 3x plus 27 equals 12. Negative 3x equals 12 minus 27. What is that? Negative 15. And then I can do this, and x is 5. Don't forget, you have to ask yourself, can x equal 5? Is that okay? No, it is not. That would make this denominator 0. If you are solving a rational equation, if your supposed answer, the solution that you come up with, if it would make anything, any fraction, anything have a denominator of 0 anywhere in the course of the problem, that's a no then. You have to dump it. You have to throw it out. It's not okay if at any point in the problem you have a 0 denominator. That's never okay. I hope this has helped. Let me know in the comments, and I will see you around. Thanks so much.